Oh, pardon me. All right, guys. I had a little bit of trouble with recording of recent. And so, believe it or not, this is the third time I'm going to make this recording. This one will work. All right. So, I think everybody probably had no problem with this picture. Identify the following in the right triangle QRS. Okay, the big triangle. The hypotenuse you all said was QR. The segments of the hypotenuse, QT and TR. No worries. The altitude, if you remember, goes from a vertex and is perpendicular to the base. So they are looking for, in this case, ST. Okay? Because that's the altitude of this right triangle. It's one of them. There are three. Because this is a vertex and this is perpendicular to the opposite side or side containing the opposite side. And Q is a vertex and it is perpendicular. So QS, RS, and TS are all altitudes, but we're working with geometric means. And so we're looking for that. They're asking for that altitude. The segment of the hypotenuse adjacent to leg QS. So here's leg QS. The adjacent side is QT. All right, that piece is done. So to do the next part of the homework, these four, what I recommend you do, just because we're still learning how to organize and how to organize our correspondence, is just draw one triangle, draw a bigger triangle, and draw a third triangle. Just sketch out three triangles and then label them appropriately. So on my smallest triangle, H is the vertex with the right angle. And D is up here, and E is over here. Okay, so let's label the middle triangle. H again is at the right angle. And okay, I'm talking and thinking about other things. All right, H is this piece, this vertex, but this is E, and probably some of you were hollering at the computer or at the video saying, hey, fix it. So H-E-D, H-E-D. Okay, let's get rolling. H-D-F. And then for the big triangle, D is the right angle, and E is the short leg, D-E-F. So now it's real easy. It doesn't matter which direction you go on the first triangle. You pick it. So we could go H-E-D, we could go E-D-H, we could do D-H-E, we can go the other way. So let's go the other way, D-E-H. And then this one would be F-D-H, and this one would be F-E-D. Okay? So that's how I would do all three of these triangles. Just for time's sake, I'm going to give you the answers so that we can move on to the rest of the worksheet. Okay? So NOP, besides I've done this video a few times. Oh, it's crashed once, and just things that are beyond my control. I'm having to redo it a third time. Hopefully this isn't the norm. It hasn't been, but this is only my second round of videotaping. So these are the answers that you should have for all four of these triangles. All right. So moving on. This problem says, the altitude of the hypotenuse of a triangle divides the hypotenuse into 45 inches and 5 inches. So the first thing I want to do is I want to draw that right angle in, okay? And if you look at these pictures, it doesn't go through the corner of that 90. It's always above it. And if you notice, I drew it above it. Not only that, mine looks perpendicular. But here's what they're saying, 5 inches and 45 inches. Okay? So the altitude divides it into 45 inches and 5 inches. I got something in my throat. What is the length of the altitude? Hint, use right triangle below in your knowledge of special right triangles. Well, actually, I think I misstated this, or they misstated it. Think about the geometric mean that we've been learning about in this unit, because I can break this triangle up into two triangles, small and medium. And if you think about it, the short leg on the small is 5. The long leg on the medium one is 45. And the long leg is X, and the short leg is X. So we can now set up a correspondence with these values. We could say X is to 45. X is to 45 as 5 is to X. And that ends up, if we cross multiply, we get X squared and then 4 times 45, right? Well, 5 times 45, not 4. 5 times 50 is 250. So this becomes 245, doesn't it? 5 times 45. No, 225. There we go. Boy, it's a little early. So 5, carry the 2, 22, 225. That's better. So to solve for x squared, I'm going to take the square root, and I'm going to get x is equal to 15. So now we found x. One of the properties of right triangles is this piece is to the altitude as this piece is to the altitude. Okay? So 5 is to the altitude as x is to, I said that backwards, didn't I? This piece is to x as x is to 45. Or 45 is to x as x is to 5. That's where the geometric mean comes in this problem set, is that, remember, the geometric mean is you take two numbers and multiply them together, 5 times 45, and then take the square root. And there's our answer. Okay? Let's go to the back side. Got a little phlegm in my throat I can't get rid of this morning. So, moving right along with geometric mean. Find the geometric mean of the following numbers. No decimal answers, only simplified radical form. So, if we think about what we just did with that last problem, and this is a right angle, and this is the altitude, then this is 4, and this is 9, and this is x. Okay? So, we could say 4 is to x as x is to 9, and we get x squared is equal to 36, or we could say x squared is equal to 4 times 9, take the square root, and when I take the square root, I get x is equal to the square root of 4 times the square root of 9. Remember, the square root of a composite number, 36 would be composite, and 4 and 9 are two of those numbers that compose 36. I can break it up, and I broke it up as 4 and 9 on purpose because the square root of 4 is 2, and the square root of 9 is 3. So x equals 6, and that one's done. Okay, so for the rest of these, I'm just going to go the square root of 14 times the square root of 6. In this case, I'm not going to break it up like this because I need to see something. I mean, I can break it up many different ways, but I can see that this is 2 times 7, and this is 2 times 3. And look, I have a pair of 2's under the radical. So if you remember, if when we do factor trees for simplifying radicals, what we did was, well, 6 times 14 is 84. What we did was we made a little factor tree divided by primes. So 84 divided by 2 is 42. 42 divided by 2 is 21. 21 is divisible by 3 and 7. And we found a pair. We would pull out, it would take 2 to break out of radical prison, the way I taught it to y'all. So you would write 2 outside, and what isn't a pair, whatever's left, goes back under and gets multiplied. Okay? There's my lengthy explanation for that one. So now let's go to this one. So I can see that the square root of 9 is 3, and the square root of 30 is 2 times 3 times 5, right? 2 times 3 times 5 is 30. Since there's no pairs, then it's simply going to be 3 times the square root of 30. Okay? 25 and 49. Notice I'm not multiplying them, I'm just taking the square root of them. If I look at them and they're nice and clean, what I mean by that, this perfect square and this perfect square. 5 times 7, 35. Done. Square root of 4. So I'm going to have 2 times the square root of 120. Thinking about 120. Multiple ways to do it. You can think about it and use what you know about 20. Well, isn't 120, isn't that 4 times 30? 4 times 3 is 12, and is it, yeah, 30. Well, we know that 30 from this problem up here doesn't simplify, so I can take the square root of that and the square root of that. So I get 2 times 2 square root 30, 4 root 30. That's that answer. Square root of 9, square root of 18. 3 times the square root of 9 times the square root of 2. I just took 18 and multiplied it this way, divided it up this way. So 3 times 3, 9 root 2. Okay, starting to go with a little quicker pace because there's a lot left to do. And I've explained. So here I hope you see that it's 4 times 8, it's 32. Here it's square root of 5 times square root of 25, it's 5 root 5. Here it's square root of 12 times square root of 16. We know that's 4 times the square root of 4 times square root of 3. What did I do? 12 is 4 times 3, so it's 4 times 2. So it's 8 root 3. Done. Okay? All right. Now, for this problem, I'm just a very visual person, and a lot of you are as well. I just make 3 triangles. Okay? I make 3 triangles, and I relabel. This is T. That's a lousy T. It looks like a 4. This is T, and the long leg is Y, and the hypotenuse is Q. So for the medium triangle, the short leg is Y, the long leg is S, and the hypotenuse is R. And then for the big one, the short leg looks like Q, correct? Yep, Q. That was just a lousy Q. Wanted to redraw it. And then the long leg is R, and the hypotenuse is X. All right? Why do we do that? Well, now I have 3 similar triangles. These are all 3 similar. We've already proven that in previous homework. Coffee. That's helping. Now, Q is to R as I don't know is to S. So I want to find a correspondence between 2 of these 3 triangles. Like Q is to R as I don't know is to, whoop, that doesn't work. How about Q is to R as T is to Y? Aha. These 2 and these 2. You see that? Because look, Q is to R. I'm just using, see my 2 fingers. Q is to R as I don't know, T is to Y. This is T. So they have to match up. Okay, and I'm going to circle this for the first one. I'm not going to picture will get way too busy because I'm going to use these 3 triangles for all 6 of these problems. Now, I'm going to try it again. S is to Y as something is to T. Y is to T. Look at that. This guy's Y. All right. Is this easy? Seems like it, huh? T is to Q. T is to Q. Where's T? Here's T. So T is to Q as Q is to X. Aha. Q is to X. Q is to X as T is to Q. Oh, this is the same thing, just in reverse, huh? I think it's right off the homework set. That was pretty weak, especially to put them back to back. So let's see. S is to R as, no Q in there. So S is to R. S is to R as R is to Q. See that? S is to R as R is to Q. That looks like a geometric mean too, doesn't it? So does this. So does this. Not all of them look like geometric means, but this one is, this one is, this one is, maybe this one will be. So within this nested 3 triangle right triangle, we have 3 geometric means, okay? So there's relationships within these guys that are means. So what goes with what's pretty important. And so looking at this last one, ooh, this is a geometric mean. Something is to R as R is to X. So here's an R and here's an R. S is to R as R is to X. How's that? It looks like this is S. S is to R as R is to X. And it works. So this is like the easy geometric mean to remember, okay? I'm visual. I always set up the triangles. All right, that's the first half of the homework. And I am going to stop the video and make a second video.